Hello, everyone, and welcome to Developing with CockroachDB Office Hours. This is a developer-focused success program with a series of workshops and office hours to help you tackle your biggest developer aspirations. We want to help you get the most out of CockroachDB, utilizing what you know so well with SQL and Postgres. If you've taken Cockroach University and you are a new to intermediate user of the Cockroach serverless, bring us onto your journey. We want to help you learn how to make the most of the platform and help us improve your experience. Today is Office Hours with Bram Grenier and Alex Enton. If you have been keeping up with us, you've seen Bram on quite a few of these live streams, but if you're new, I would like to go ahead and introduce Bram. Bram,
hi, everyone.
Welcome.
I wasn't sure if you wanted me to talk.
Yeah, talk to me about your path here at Cockroach Labs.
Let's see. I've been at Cockroach Labs since right after it was founded. I started off as an engineer. I did 4.5 years of just straight engineering. And then I switched to the dark side and I joined the revenue team as an enterprise architect. Which is a lot of fun because I get to talk with real customers using this thing that we built out of nothing. Well, not nothing, lots of tools and everything else, but still really cool. And now I'm the manager of the enterprise architects that work specifically with financial services, so large enterprises like banks and whatnot who are using Cockroach. Hi, Rain.
Awesome. Quite a journey. And today we also have Alex Enton. Alex, I believe this is your first live stream. Welcome.
That's right. This is the first time I'm using a web conference.
Nice. Exciting. So talk to me about your path here at Cockroach Labs.
I'm an enterprise architect with Cockroach Labs. I don't have a long tenure, as long as Bram's tenure, but I've been a few years with the company. So I gained some of the bits of knowledge that I'm happy to share with you folks today, perhaps, if there is an opportunity. And as all enterprise architects in the group, our purpose in life is to make the customer successful, which is, I guess, what we are wired to do.
Yeah. And I'm Lori Morita. I'm a project manager here at Cockroach Labs. I've been here for about 7 months, so not as long as you two. So if you're listening, ask us any questions for Alex and Bram, post them here. And I want to remind you, if you're watching this somewhere else from YouTube, be sure to subscribe on YouTube too. YouTube is the only place where all the videos are saved and you can rewatch later.
Well, the dark side has revenue.
Does the dark side have cookies?
Yeah, you're closer to the money, so I guess that's the cookies. But for the most part, I found the difference between straight engineering and doing this work and working with customers is that I had made a lot of assumptions as an engineer about how Cockroach would be used, and a lot of them were very wrong. And I find working with customers directly gives me deep insight into sort of more empathy with, because I've been a database user and I've been a database operator in previous roles and whatnot. But we built Cockroach, and when you're building it, you have a very clear vision of what you think the customer should do it, how they should do things, and we shouldn't. It's very hard to sort of disentangle that from thinking about sort of other users and other use cases and whatnot. And once you're exposed to more of them, it really helps. The earliest example I can think of. Sorry, Rain asked here. Can you elaborate on some of these examples? One of the earliest ones was when we were building Cockroach. We didn't. We had, we had the SQL layer, we had ranges, we had range leases, and all of those good details. And we added a feature called Follow the Workload. And the idea was wherever the queries were coming from, the leaseholders would move to where the queries were. This makes sense. If you've got a large table and you've got customers in Japan and Europe and the US, originally we called it follow the sun because it was where are people currently using it. But obviously some applications go on during the night. So we renamed it follow the workload. So where are people actually querying that table right now? And we could move the leases accordingly. However, when talking with a customer, they want the performance to be predictive and consistent. So being able to say, well, don't worry, after 100 people or so query, issue some business query. Let's say we'll use the mover, for example, hail a car or whatever from Japan, the leases will start to move there. That's not good. What a customer is looking for, what a user is looking for is, it's going to take this much time in a normal use case. And in a failure mode, it's going to take this much time. And so what we added was the leaseholder preferences. And it seemed like a minor thing, but it's used with almost everyone I know that uses Cockroach uses the leaseholder preference instead of allowing the default of follow the workload the moment you start to do multi-region and get to those larger deployments. So that's sort of a example. Like I remember working on the follow the workload stuff, and it was great. And it's a really cool idea that the database should improve as you use it. But what you need is predictability. You need to know the latency that it takes for this operation for this query to take place every time. And so you need those proper bounds, and you don't get that without using something like leaseholder preferences.
I have a bit rambly that came to mind. Sorry, Bram, I didn't mean to interrupt.
No, go ahead. I was just saying it's a bit rambly. I wanted to make sure that was.
Your story is a good one. So here's the one that came to mind. So I've been working with a customer, and he at some point said, "Well, we actually have a query that doesn't perform well." I looked at the query, and the query looked well. First of all, it was 5 pages long, and second of all, it was, I couldn't understand what the query is doing. So we started digging about the use case a little bit, because actually it's a customer who is using us in a number of different applications, and they had good experience with one. So I decided to use us in a different use case. And the use case, to make the long story short, was about traversing a tree, a graph. So if anyone tried to use graph traversal in SQL, well, there is actually some PhD work that I figured exists on this. It's not a trivial thing to do. And it's also not the most natural thing to do. So without going into gory details, we made it work, but it was a very interesting computer science exercise.
It should be a recursive CTE, right?
I'm hesitant about how we've been solving problem because of the concerns about privacy, etc.
Okay.
I can't really reveal too much about the use case. About what it was all about, etc. But the idea is it's a social network, and the social network, people need to see connections, etc. And there are different ways to solve the problem. So we had to pivot a little bit, and instead of graph traversal, it's actually in these tasks, there's a question: do you want to pre-process the data before you put it in the database? It's going to take a little bit longer, but then it will be quicker to query, versus you put it in as is in the relational structure without pre-processing the data, quicker to ingest, but then it takes longer to query. So that was, as I said, it was a pretty cool computer science exercise. Not very expensive.
You can do both of those too. You can have some type of separation between the ingestion of new data and the searching.
That's what engineering is all about, is to find the the optimum solution for the requirements. Yes.
Then again, every time I see, every time I'm not using third normal form, I get hurt a little. I can feel the pain.
Rain also asked another question. Are you three subscribed to the YouTube channel? I know I am. Are y'all?
Of course I am. I've been subscribed to the YouTube channel back when it was silly pictures of of Carl.
What about you, Alex?
I don't think I am, but I will. That's going to be my homework, I guess.
Yeah. I'll put it in here again, youtube.com/CockroachDB. You can subscribe using that. All right, we have another question from Rain. What kind of questions do you ask when getting to know a new potential customer in order to figure out their use case and problem points?
That's more salesy.
I'll take a shot.
Yeah.
I actually have a approximately 30 questions questionnaire that pretty much gives me a very good, if a customer is open to doing a little bit of work with the questionnaire, it gives a pretty good idea. So you can't just, it's not going to be just one question, 2 questions, 5 questions. You have to go in categories, and you need to get a lot of facets just to get a high level impression of what it is. We can certainly share the questionnaire. There's nothing secret about this, and if there's interest, we can follow up with a pointer.
I'm interested. I've never seen this questionnaire.
Oh, yes, you did.
Did you send it to me? Maybe I don't remember it. Yeah, for me, it start with the database itself as a tool. So the goal is to find out what's the business use case first, and then figure out how the database fits in there. Rain has a follow-up here. It says not to sell, but to architect. Yeah, now obviously they're similar. It's just normally as enterprise architects, we're working with people that have already signed on, agreed with that Cockroach is the right database for them. But we do sometimes work on new use cases with them as well, potentially. Yeah, it's look at the business use case, make sure that Cockroach is a good fit, because we'd never want to be in a place where we wouldn't be. And then it start to break down sort of the size of data that they're looking at. And I find you go in different directions every time. I don't have a strict script, but maybe I need one, because that sounds really good, Alex.
No, I actually go by areas. So one is capacity, to your point, Bram, right? So we need to understand the capacity in terms of how much footprint of data we would need to accommodate. Then there is a question about characterization of the workload. What's the element of concurrency? What's the expectation for the latency? What's the profile between reads and writes? Very high level. If we can get into the details about, if we can break it down to selects, updates, deletes, that would be good. How do you have a schema? If you have a schema, can you show it to us? The schema can be logical definition, whatever. Entity relational diagram would be fine. So I'm just putting aside everything that Bram mentioned, which is very valid precursor to the conversation, the use case, etc. I'm just looking at the database as a database practitioner in terms of how do I need to configure the database to accommodate the requirements? So I think we talked about capacity, we talked about the profile of the workload, then we talk about availability and the SLA. And availability is what kind of situations you need to be able to survive. What's the locality, topology, geography of what you're trying to achieve. And those are the main areas, I think. And in each area, there are probably 5-6 questions just to get more quantification, so that we can meaningfully envision the cluster for the requirements. And by the way, right after that, the next exercise is, presuming that there is interest to continue on both sides, we talked about sizing the cluster, and sizing the cluster is a fascinating topic. It actually sometimes is being sort of neglected, and if we look at the most common problems that the customers run into in the real world, a lot of this is because a platform and perhaps under-provisioned, or perhaps using nodes that are not balanced in terms of the resources that are allocated to the node. So it becomes from the questionnaire, we kind of migrate into the sizing exercise. From there, it would be a conversation about best practices for the particular choice of the platform. So whether it's bare metal, and we have guidance for every platform, pretty much that we support, which is public cloud, bare metal, Kubernetes on top of public cloud, and all kinds of permutations. And from there, presuming then we have the cluster, then we start talking about architecture, and then finally, it's about how we achieve operational stability, which is as important pretty much as a good design of the architecture. Over to you, Lori. Sorry for being perhaps a little.
Let me add let me just add my favorite part is I love talking about the survivability of Cockroach and designing that into the system that we're building. So specifically looking at, okay, you're running in these specific data centers, and what are you looking to survive? What are you worried about risk-wise? Because this will run in any data centers, be it public cloud, private cloud, whatever it is. But talking about, do you want to lose an availability zone and just keep going? Do you want to lose a whole region? Do you want to lose, like, how many nodes are you willing to suffer a loss at once? And designing the failure scenarios, I find very intriguing. I just enjoy doing that part.
And I like the sizing and platform practices, because that's one that is very fundamental. So before you build the house, you pour the foundation. That's the foundational part. So I like that part more, and that makes myself and Bram kind of a good duo when we have when we work with the customer. We have them covered in all facets.
Looks like we just got a question from YouTube. Should I learn a new language to use CockroachDB?
The only language you need is SQL. I don't know what other programming languages you use, but whatever you already use, there will be a driver for it. Because Cockroach talks the Postgres SQL and uses the Postgres wire protocol and everything, most drivers already work or will have a driver that works. The important language to know is SQL overall. It's to get started in it's fairly easy. To get in some of the weirder stuff, like how to do a graph traversal, that gets a bit tougher. But there's plenty of tutorials out there. I don't have a good one on hand. I remember I was asked this the last office hours I was in, and I didn't have one ready.
You can always check out our docs.
We do have a live play with SQL in our docs on Cockroach. So I think we have that. There's a link somewhere.
And I also gonna spill the beans. We are working right now on a SQL class in Cockroach University. So it's gonna be available, I think, within a relatively short period of time. For those who are interested.
Yeah, so Joyson, SQL is the language for relational databases and has been for a long time. So yeah, I think that's really the way to go. It's a very useful skill overall.
We have another question coming in. What tools are available today to do database backup and restore?
Do you want to take that, Alex, or I can?
I would just share my thought on this at the high level. I think there are plenty of tools, and there are plenty of ways to do it inside the database and outside the database. My experience working with a number of databases on the inside, being part of the company that would make a database, you're always going to be better off using native tools. And we, of course, provide the tools. Our backup is pretty robust. It's parallel. It's a cluster. So every node is going to back up its share of the data. And so it's parallel, it's well-performing. You can choose the destination, and you can take a full backup, or you can do incrementally, so that almost quasi-continuous, not quite continuous, but you can do it in a pretty regular interval, like every 10 minutes take an incremental backup. So you have a pretty close restore point when you need it.
All right, we have a few questions. Joyce and John, thanks for the answer. What are the advantages of CockroachDB over MongoDB?
They're very separate beasts. With MongoDB, you're dealing with eventual consistency. It's document storage. It's a completely different type of database. Cockroach is a consistent database. So every transaction, you're guaranteed that it's going to go through. You can do some stuff with Mongo now where you can add in ACID consistency to some stuff. But Cockroach is a SQL database. It's relational. So you get secondary indexes for faster lookups, foreign key relationships, and other constraints that you can add. They really have more or less different, I would use them for different things at different times. I don't know, Alex, do you want to elaborate on that?
I think the 21st century is the century of the kind of pick the database for the job, right? It's the right database for the tool. I think the era of general purpose databases is kind of long gone. And my answer would be is pick the right tool for the job. If you need to store documents, MongoDB is the tool. If you need to do relational processing, OLTP style, CockroachDB is the tool. And it's actually not going to be a secret that I recently worked with a pretty large enterprise customer, and there is no conflict there. They actually have both a document database for the use cases. It's a very large enterprise. They use document databases for specific use cases, and they use a relational database for its own use cases. Of course, we can go into the first question, kind of make the full circle to the first question, talking about the unusual use cases and that we never expected. We actually can do a document. So if you take, for example, a JSON document, you can actually put it into our product, and we have inverse indices to index the fields in the JSON, etc. So it's actually going to work reasonably well. However, if you really need, documents, you probably would use a document database. The database is purpose built, and it would be as much of an unnatural act to try to use Mongo for OLTP processing, general purpose OLTP processing. It's just not I guess it can be done. It's just not a very natural way to solve the problem.
I've seen it done. You tend to need extra systems around Mongo to ensure you're getting the consistency. And however, Mongo's survivability is great. Whereas with Cockroach, we require always at least 50%. You need a quorum to survive to be able to ensure the data is correct and consistent. So it depends what you're looking for. And and by the way, for document, what we mean here is essentially JSON blobs, but it's a document in Mongo's style of talking about what a document is. So schema-less-ish, because you always do need a schema, regardless if you're storing JSON blobs or not. Somewhere along the line, you have a schema and you're storing it somewhere. With a more classic style, SQL-style relational database, those are more explicit usually. But yeah, as Alex said, we have JSON columns if that's what you want, and you can do inverted indexes and all of that.
Nice. All right, I skipped over this question earlier.
From our team at reInvent.
Yeah. So this was an internal question. We are currently at the AWS Invent conference this week and have been asked a lot at the booth about how we run on AWS versus other clouds, and also how we compare to Aurora. What are your thoughts on this?
Well, for how we run clouds, Cockroach is cloud agnostic for the most part. We are. And we even try to minimize the amount of code that's specific to a specific cloud that we would add into Cockroach directly. How you can run it in the cloud, well, that's entirely up to you. You can run Cockroach on bare metal. You can run Cockroach on a Raspberry Pi, but I wouldn't do that. And well, I wouldn't do it for anything except for a demo. But Cockroach can be run in Kubernetes, so you can use any of the cloud Kubernetes. You can do cross-cloud. You can do you can use VMware and virtual machines, or any way you want to run Cockroach. It should be relatively easy to get started. And the best practice depends on what the it depends on a bunch of factors. When dealing with specifically when dealing with companies, it's trying to figure out how they already implement other databases or systems and try to fit into their setup, as opposed to forcing them on a different path. As far as how the clouds compare to each other, well, this is where we have the cloud report. I think it's coming out in January, maybe. I don't know for sure. I'll say January, early in the new year. I know that the tests are being run right now, and we're working with all the with the three major cloud providers to figure out how to best tweak performance for their cloud. Later this spring. Okay.
Later this spring.
Okay, later this spring it is. I know we're actively working on it.
So
yeah. I don't know the when it's going to land. I just know it's going to be really good because the last one was great, and it really showed some surprising results. To talk about the difference, like comparing Cockroach to Aurora, besides the fact that Cockroach can be multi-cloud, can be hybrid cloud, you can move from one cloud to another, so there's no vendor lock-in there. The finer points, Alex, do you want to take some of them?
I would actually kind of step back and would say, so if you are, let's say, a user, they both are relational databases, and even going further, there are two different engines for Aurora. Aurora is a sort of marketing name, but underneath it can run. It's a proprietary engine, but it can run in the compatibility mode with Postgres and MySQL. So if you pick, for example, Postgres, it's going to look to the user very, very similar. And frankly, until you pop up the hood and look on the inside, they look very similar. On the inside, couldn't be more different. The way we distribute the data is fundamentally different. I mean, dramatically different. To the point that what we do is we use dynamic sharding. We break the data into ranges. The ranges are going to, depending on the situation in the cluster, are going to be moving around the cluster and kind of meeting the goals, et cetera. So the data is always rebalancing, which gives us this great elasticity, which is not something that Aurora can ever possibly do. In terms of, I think the other major point, and Bram mentioned that, and I just wanted to emphasize this. We are an independent software vendor, which is, by the way, why when somebody asks, well, how do you on AWS versus others? We are independent software vendor, right? We are platform agnostic. You can take us. You're not going to be locked into a particular solution in a particular cloud. Aurora makes you creates this affiliation with AWS. If you like it, great. If you don't like it, well, you have to find yourself another database. The nice thing about what we do is we can run on AWS, same database, or you can run it in Google Cloud, or you can run across both, or you can run across three clouds, et cetera. So there's no vendor lock-in, and you can always change the courses on the platforms. And that also gives you competitive advantage when you're negotiating perhaps the rates with the cloud vendor. Think of that.
Yeah, now Aurora is a great database. It's a really well designed and well thought out, but it's still bolting together older systems instead of with some new shine on it, instead of creating a whole new database from scratch. And that was the advantage we have with Cockroach, because we're able to do things that are not really possible or take a lot of work to get right on the older. When you take these sort of hodgepodge systems where you put some things together. but I don't want to speak poorly of it. It's a great database, and I really like some of the design decisions they made.
We have another question.
Of course it will, Sid. Will Cockroach pass Jepsen tests? We run Jepsen tests. We run Jepsen tests nightly, and we have a collection of different Jepsen suites. Would we like to have it vetted again properly, like we did years ago? I think I would like to. I don't know what the engineering team is planning at this point. I would hope so. But yes, we absolutely pass the Jepsen test. Whenever one fails, it's an all hands on deck. What red alert? What is going on? What did we miss? Also, when we designed our most recent transaction system, we first modeled it with TLA Plus to ensure that it did what we, as best as one can. It doesn't prove that it works, but it gets you much closer and finds a lot of the bugs that you wouldn't think of. So, yeah, consistency is our #1 priority.
And earlier you mentioned there would be a Cockroach University class for SQL. Looks like it's already on there. There's the link. And then also, if you want to view the latest cloud report, here's the link. Okay, Adrian, I did skip over this question earlier. So, do y'all have any domains you've purchased for a side project and never used? And could you tell us about one and how do you use CockroachDB with it?
I don't know how to answer the question. Maybe a little bit more color. What
I wouldn't want to air some of the
from us, or what's the genesis of the question?
No, it's just it's a silly question. It's fine. I have a lot of side projects, but I don't normally make domains for them unless I'm really serious, and I try to, yeah. I do own a bunch of weird domains here and there that I just maintain, but I'm not going to say any of their names.
Yeah, and for those listening, let us know what projects you're working on and how we can help.
Mm-hmm.
As a reminder, ask us anything you want about CockroachDB. We are here to help. This is not your only path to support. Please reach out on our forum, community Slack, check out our docs pages. They're super helpful. Our next workshop is in 2 weeks. So it's going to be on Thursday, December 16th. We will not have a workshop on Wednesday, December 15th.
So I can just ask Alex questions.
Yeah, let's hear that.
I will pass to Lori.
So let's see. Yeah, you already mentioned something recently that you were trying to optimize around. For any of the customers that you work with, what's one of the failures you've seen recently where Cockroach survived, and maybe one where it didn't? No.
Actually, I had another anecdote maybe for not just entertainment value, but perhaps with some utility. I've been working with a customer who is actually building their own service. It's analytical service using CockroachDB as a metadata. The user customer base, etc. That's the extent I can describe that. So they are offering their own service in the public cloud on top of one of the providers, and we are the engine to manage the metadata, user information, usage, etc. So survivability is very critical, and they are running across different topologies, including some presence in Asia, some presence in Europe, and it's some in the US, of course, and in Americas, and it's a global service, etc. And they specifically were interested in region level survivability. Which is one of the, I mean, there's a lot of talk about surviving availability zone failure, but this is the situation about what are we going to do if the entire region, like Asia Pacific, for example, is not available. And the specific question was, have you seen any? So that was a good opportunity for me to go into our operations. As you folks know, we also operate CockroachDB as a service, so you can. It's called Cockroach Cloud. So you can just. So I wanted to get the color about how frequently we've seen availability zone failures. How frequently? I mean, what's the statistics that we've seen, perhaps in unofficial, about regional failures that we've seen in our operations? And I got some interesting data points. Unfortunately, I don't have it right in front of me, so I would have to speak from memory. But the point is this: we did not see, particularly in AWS, we never seen a regional failure, a hard failure where all availability zones would not be available. What we did see, and there are once in a while we've seen anecdotal evidence on TV that, I mean, the entire region is no longer available, etc., and people are scrambling, but it never affected our operations for whatever reason. We know that it's just a matter of time, it's going to come, but we haven't seen any. What we did see was shared components failure at the regional level. So for example, there are like load balancers, for example, there are regional resources. Those specific resources can fail. And when they fail, they actually would effectively cut off the access to all the nodes in the region. So while the region is technically running, you actually cannot use the nodes. So effectively, it's a regional failure, right? So we've seen those. I think it happened a couple of times, and the outage was probably something within. I got a sense it was between 30 minutes and 2 hours, and the service was restored. So we did see those. We did see several times availability zone level failures in our operations. So those are kind of anecdotal data points, and that's kind of my story on this.
We did have another question. Another question we're getting at the booth is about why Distributed SQL is better than MySQL. What are the advantages?
This is a strange question because I think that it shouldn't be better than MySQL. It should be more sort of a single SQL, classic SQL database. So talking about, Postgres, MySQL, Oracle, or SQL Server, stuff like that.
What is a distributed SQL, though?
Yeah, the difference here is that a distributed SQL like Cockroach, it means that you're still SQL, but you can scale horizontally instead of just vertically. So that's the major advantage of it. And with that, it allows you to do more interesting things where you can have multi-region patterns and be able to have faster access to data so you have the data where the queries are coming from, and things can get interesting. But that's the major difference, and that's the major advantage. Instead of having to buy a bigger and bigger machine and eventually going to specialty hardware, you can run on commodity hardware or in the cloud and run on containers or virtual machines and spread out horizontally to a fairly large size. Did that cover it, Alex? I think that does, right?
It's a very good answer. I'm still struggling to understand. Is this about, I mean, comparing CockroachDB to MySQL, or this is comparing, I mean, SQL language to MySQL's dialect, which it could be. I think there is some ambiguity in the question. I'm not sure which one it is, but I would actually throw in something for pure entertainment value. Does the audience know that CockroachDB is a database and MySQL is not? And with this shocking point, which I stand by, it's a true statement. Do you guys want me to explain why I said that?
Go for it. I know we've had this philosophy, this discussion on semantics before.
This is a cool topic. So MySQL is actually not a database. I mean, that's a true statement. MySQL is a SQL shell. It comes with parser and syntax checker and the optimizer even, but it requires an engine. And what makes a database is the complete stack. And MySQL design is pluggable engines, and you can find probably a good 100 of them. It comes with a default engine called InnoDB, and that makes MySQL with InnoDB a database. But MySQL by itself is just a SQL shell. To Bram's point, the engine is what makes it potentially distributable. And there is no shortage of engines, pluggable engines for MySQL that are trying to solve the problem of the original MySQL design, which is the cluster of one. And when it is a cluster of one, and your data doesn't fit into one, you have a choice. Either you have a lot of those MySQLs and you operate them, or you write something on top of it and you start sharding data and creating a layer over it. It's a valid way to do it, but we solve it kind of out of the box, right? So you can focus on your business problems to solve and development problems to solve, not worrying about, doing manual sharding of data across MySQL instances. I'm trying to keep this kind of entertaining a little bit.
Yeah. Partitioning is no fun. That's just, I've done it. I've seen months of developer time wasted due to partitioning, years of developer time wasted due to partitioning.
I think, in my observation, it works to a point and scale, right? The moment you have to manage the number of instances that you have to, individual instances that you shard over, is getting closer to, number in the hundreds. And the largest I've seen was 3,000 for one of the customers. It just becomes unbearable in terms of operating them. And operating one cluster of many nodes is a lot more palatable to the IT organization versus running hundreds of individual installations of MySQL.
When I was at Microsoft, I was in Bing Shopping for a while, and we maintained, I'm trying to remember the exact number, it was around 25 separate SQL Server instances, one per day, with a list of products that to be sold. This is back when Bing had shopping. Every day was a new shard, a new partition. It was really hard to write queries against that to fix data, and to turn that into something that could be searchable. It was there was a senior engineer on the team who spent 6 months, 8 months, I think, building another database to sit in front of this collection of databases, just so you could do a query and look things up. And of course, the moment you do that, you break the ability to do transactions, and you break the ability to do anything except for point lookups and point writes. And then suddenly, if you're doing that, why are you using a relational database in the first place? So
I have a kind of experience. I'm gonna go full Monty and tell folks about experience. So I've been with a startup. I won't name what it is. It didn't make it, but the idea was to have sharding over MySQL. So essentially, creating what Bram was describing is that if I need to do a transaction across multiple instances, individual instances of MySQL, and provide transactional guarantees, etc., We worked on this for 2 years, and the startup ceased to exist. It just basically didn't make it technologically. It's a lot harder problem to solve in general than people think. It is, and I speak from firsthand experience. You can solve the problem for sure for specific requirements. In general, it's very difficult to do.
Yeah, this goes back to the that points right back to the when I was talking about sort of trying to bolt a system on top of other ones instead of building something from scratch.
Yeah, and the fundamental issue there is that the layer has to have hooks into the engine, and you don't have those, and that's where it becomes a stopping point, basically a roadblock, a major roadblock.
So, question from Alexandre. What biggest differences between Google's Spanner, I'm assuming, and CockroachDB? So Spanner influenced Cockroach. The lack of having Spanner outside of Google was why Spencer wrote the design doc in the first place, because he wanted what Spanner was, but it wasn't available and there was no open source version of it. And so that was the early inspiration for Cockroach. But we have very much diverged from that a long, long time ago. I'm not up on the exact spec sheet. Let's see, Spanner does... they've got Google True Time behind it, so they're able to, everything can wait. Like, I can get into really low details. That's probably not what you're looking for. I'm trying to think of sort of on a higher level. Similar to, so Spanner is a great system, a really great database, to be clear. But with it, originally they didn't have a full Postgres compatible SQL. They had Google SQL, I think is what they called it, and it had some Spanner extensions in it and things like that. They just recently released a Postgres one, I think, if I remember reading the news on it correctly. You're going to run into similar problems of being stuck on a single cloud. If you're running Spanner, you're stuck in Google land, which is fine. It's up to, that's a business decision. Otherwise, the way in which writes are done in Spanner, they all wait. I don't have a good narrative here. Alex, do you maybe have?
I usually answer the question in a fairly simple way. So there is definitely an inspirational element, right? Even though CockroachDB was written from scratch, it's not a copy, it's not a fork. It was written from scratch. The inspiration and the fundamentals were from the Spanner.
From the Spanner paper, yeah.
I generally position this as Spanner version 2, version 3. It's a next generation Spanner because that's how technology evolves. You take the best ideas and then you evolve on top of it, and that's exactly what we've done. So yeah, think of this as the next generation Spanner is perhaps would you agree with this, Bram?
Yeah, absolutely. That's a much better narrative. I was trying to pick apart the details. Like our transactions have evolved drastically from the early inspired Spanner ones. Yeah, there's a few talks you can take. I think we have a big blog on it as well, where we talk about some of the newer stuff we're doing with transactions. We very much diverged 5-6 years ago from just trying to make Spanner an open source. We never even, that was never even the goal. The goal was to create a database inspired by the Spanner paper.
I'll give a couple of specific kind of interesting tidbits. So the way Spanner operates and the consistency guarantee is coming from the use of a hardware device called an atomic clock. That's a requirement for Spanner. We did it very, very differently. We don't require an atomic clock to be installed, even though it's not that expensive. Nonetheless, we don't require an atomic clock. So we actually operate and provide the guarantee, even though the clocks on the different systems can potentially drift apart. How we do this? For that, see you next time, right? We'll ask in the next session that we're gonna have maybe a few weeks from now.
Mm-hmm. See, for some reason, the number one question still being asked is, how did we choose the name Cockroach? Lori, do you know this one?
Well, we're named after the cockroach because cockroaches are resilient. So just like cockroaches, CockroachDB, it's nearly impossible to kill. I believe cockroaches can survive a week without their heads. CockroachDB can thrive anywhere. I believe cockroaches can live basically anywhere, and we scale fast.
Yeah, and if you kill one, you know there's many, many more.
There's hundreds more.
Yeah, and we we're started in New York, so, and I can assure you there are a lot of cockroaches here.
Oh yes.
I think I've heard two stories. One is the technical, which is, yeah, it's a pest. Try to kill it. The other one is you would hear if you talk to more like marketing people, is when you build a company and you're looking for attention and nobody knows you, right? And one way to do it is to have something, ridiculous in the name. And the folks, so the story I've heard is that the founders basically kind of were looking for a shocking name in many ways that would attract attention. This came up, and then, but they did not finalize the choice. But at some point, it sort of caught on, and it did make sense because it's a pest, right? It's hard to kill and all that. So there was some connection to the technical merits of the product. And at some point, they said, "Oh, interesting! It actually works." And here we go.
Yeah, it is definitely a very memorable name.
So you need to have an audacity to come up with a name like this. And
yeah, well, that was Spencer.
There we go.
Yeah, yeah, and then the what's the post-nuclear war? It's the only thing left is going to be Twinkies, cockroaches, and Keith Richards. So. We've got another one. What is this thing? Distributed SQL, more about people trying to understand what. Oh, what does? So I think we covered that. Yeah.
I have a quick thought on this, right? So that's the beauty. Distributed SQL is SQL. SQL is a language, right? How the statement
SQL is a specification.
Yeah, it's a right. So the language is
There's all these different dialects of it.
So distributed means it's executed. So one of the beauties of what we do is you actually don't have to worry about this at all. You can just worry about SQL. Run the SQL. It's gonna find its way to be executed in a cluster. And think of here's your. I certainly am not advocating to think of the cluster as a black box, but in some ways, the cluster will figure out how to execute your query in the most efficient way, as long as you follow the best practices and make sure that the data is distributable. We do a lot of things out of the box, and in many ways, it's actually simple for you to run SQL in a distributed manner, very much like you would run SQL on a single box like Postgres or MySQL. In that sense, it's going to be as a user, you would not see much of a difference.
If the best example of this is our serverless offering. So we have a serverless offering now. We host it, and you just use as much SQL as you need, and it is distributed SQL, but you don't really need to know most of the details about that. As you get further and further along, and larger and larger use cases and whatnot, sure, some of that stuff comes into play. But at the base level, you can treat it as a Postgres similar database, where you're only we have a free tier and then an actual and a paid tier as well, depending on how much use you need. And you can migrate up to that relatively easily. very easily, actually. That's kind of the point.
All right, we're getting close to the top of the hour. That's our music.
We got the fake hip hop music back.
Yeah. As a reminder, our next workshop is 2 weeks from now on Thursday, December 16th. Recordings are always available at youtube.com/CockroachDB. Make sure you subscribe. Let us know how we can help you on your developer journey. Thank you, Alex. Thank you, Bram, and everyone who asked questions. And we will see you in 2 weeks.